In this video, we are going to learn how to use a calculator to evaluate inverse secant, cosecant, and cotangents. Now you're going to notice on the calculator there is no secant, cosecant, or cotangent buttons, so we'll have to use the reciprocals which exist on the calculator in order to evaluate them. So for these 5 problems, we're going to use a calculator to find the value of each of these expressions rounded to 2 decimal places, and express our answer in radians and degrees, and if there happens to be no value, we say is not defined, and we'll discuss that if it comes up. Now we have secant inverse of 3, which could also be thought of as secant of theta is equal to 3, so what angle makes secant equal to 3? Which, if I use the reciprocal of secant, which is cosine, is what angle makes cosine equal to positive 1/3. Which, if I work backwards one more step, I can see that this expression could also be written as cosine inverse of negative 1/3, working backwards. So kind of following that loop, and now you can see that, okay, if I take the reciprocal, negative 1/3, still positive. If I take the reciprocal of 3, I can rewrite this as cosine. So when I use my calculator here, cosine inverse of 1/3. And let's see what mode I was in. I was in degree mode, so that answer is in degrees, which is 70.53 degrees. And then in radians, put it in mode, switch it to radians. Second, enter to bring the entry back. Hit enter, and in radians, it was 1.23 radians. Again, nice reminder that if there's no unit there, we assume it's in radians. And if you want it in degrees, just put the degree symbol there. So you'll see here I'm using cosine inverse in order to evaluate secant inverse of 3, because I also don't know where cosine of theta is equal to 1/3 or secant is equal to 3, so I have to use a calculator for this problem. So let's try another example. We have cosecant inverse of negative 4, which can also be thought of as cosecant of theta is equal to negative 4, which, using its reciprocal sign, I can say sine of theta is equal to negative 1/4. So the statement here is cosecant inverse of negative 4 can also be typed in as sine inverse of negative 1/4. Now I can plug that in, and right now I'm in radians. So second sine to get sine inverse, negative 1/4, and negative 0.25 radians. Now in degrees, mode, enter on degree, second mode to quit, then second enter to get the entry back, and hit enter, and it's negative 14.48 degrees when rounded correctly. Let's look at secant inverse of negative 4/3. Now we're getting to fraction realm here, which could mean that it could be undefined if it happens to be in between negative 1 and 1. Now luckily, negative 4/3 is a little bit less than negative 1, so it shouldn't fall within that range. But if I were to use my little shortcut I just talked about up here, this should be equal to cosine inverse of negative 3/4, the reciprocal of that number. And I can go through and show that same process if need be. But cosine inverse of negative 4/3, which I am in degree mode right now. Oh, sorry, that is incorrect. I make sure it's 3/4, not 4/3. I will get 138 degrees. Now you may be thinking this is a very big angle. Most of them have been smaller. But this makes sense for us because the output for secant inverse and cosine inverse is from 0 to 180 degrees. So my answer in degrees would be 138.59 degrees. And if I put that in radians, hit the mode, radian, second enter, second mode to quit, second enter to bring back the entry. I'll get 2.42 radians. Next up, we have cotangent inverse of 1/2. So this can also be thought of as cotangent of theta is equal to 1/2, or its reciprocal function tangent of theta is equal to 2/1, which is 2. And that means I could rewrite this statement here as tangent inverse of 2. So second tangent, 2. I get 1.11, which is the radian measure. And then in degrees at mode, switch it back to degrees. Second enter for the entry, and I get 63.43 degrees. Which makes sense because cotangent's output should be somewhere between 0 and 180 degrees. Now let's talk about cotangent inverse of -2. So here I can use that same trick I just used up there. I know it's going to be tangent inverse I'm going to use. Tangent inverse of the reciprocal of -2, which is -1/2. Now when I plug this in, I'm in degree mode. I will get -26.57 degrees. Now this is not the correct answer because my output for cotangent has to be between 0 and 180. Now this is approximately about right here on the unit circle, this angle. What's really nice is if I add 180 to this angle, I should get the same value for tangent in the second quadrant. Meaning I'm really looking at an angle in the second quadrant way over here. That'd be more appropriate for my answer for cotangent. So all I have to do is take that answer and add 180 degrees to it. And I get 153 degrees over here. 153.43 degrees. And the reason why I'm doing this is so I get an answer within the output range of cotangent inverse. So the proper angle answer would be 153.43 degrees. Now in radians, I have to do something very similar. So I'm going to go back, put this in radian mode. And again, I'm seeing here that my last entry I want to put back in is 2 away. So if I do second enter, it'll give me the last entry. But if I just do it again, it'll give me the previous one. So it's a really nice feature on these graphing calculators. Now when I hit enter, I'm in radian mode. It gives me -0.46, which is again right here. But I want to end up in the second quadrant. So 180 degrees in radians is pi. So I'll add pi to my answer, and I'll get 2.68 radians, which will be the answer in radians. And that is how you use a calculator to evaluate inverse secant, cosecant, and cotangent.